Okay, so my name is Moschny. I'm from Partec, and I'm going to present the software ecosystem that is formally work package 5 of the EUPEX project. And I will give you an overview so that we see what the basis is then for what is the main part of the workshop, actually dealing with the applications, optimizing stuff and so on, but we need of course a ground to work on. So for the software stack, we have those 4 objectives covering different aspects. So a management software stack for modular systems, for large-scale modular systems, the execution environment, that is mainly programming environments, tools to monitor, profile, and improve energy efficiency as semi-automatically as possible. And finally, a storage and I/O capability stack that allows workflows to easily access all the data without many cross-hierarchy data movements and things like that. And as Jean-Robert pointed out, also relying on existing software as much as possible. In that case, all the software that has been developed in the IOC stack. So that's the picture, what we have as software in the project. That's quite a lot. I will try to touch on many of them very briefly, of course, but you see it's a lot of stuff. Now, starting with the management software, we have basically 2 main software components. There is Ocean, there is the software stack that is developed and used as CA. Ocean Core is the basic distribution with package tools, and everyone in the project and also outside of the project can contribute to that. And to be able to do that contribution, the forge has been created. That is what you see on the right-hand side. So, well, a project basically around GitLab and CI, and with producing a public software repository. Of course, in all aspects of that project, always people have to port things to the ARM architecture, to the specialities of the hardware, of the blades, the low-level capabilities of the hardware. I will not stress that for each of the software components, but of course has to be done everywhere. So then we have Parastation Modulo. That is a software suite that is used, for example, in Jülich or in Luxembourg on the Meloxina system, and that is currently being integrated also with Ocean. We have a system monitoring tool with node telemetry, LLView, that comes from Jülich, is open source in the meantime. And for any, say, administrative things and information exchange, we have ticketing system that is used on the SDB, was used on the EAP, and will also be used on other systems, finally the pilot. Then we have the execution environment, so basically programming models. We have 2 MPIs. Of course, there's some overlap, but people are interested in having a choice. So we have Parastation MPI on the one hand, where we have the management system, so the parallel execution runtime, and the MPI library. We have support in there for PMX version 5, doing scalable startup. These are things that we did also in the project as Partec. Then we have Atos OpenMPI based. So I forgot to say, Parastation MPI is MPatch based, so that's important, so that you have MPatch on the one hand, OpenMPI on the other hand, with the Atos OpenMPI version, providing native BXI support, and integrating also with other components that we have in the project, coming from FORF, the optimized collective operations. Then we have some performance tuning tools, ACCO, tuning the OpenMPI performance. Not going into the details here. BHCO, toolbox for accelerating hybrid applications. So we're not only focusing on MPI, but also MP. And we have Streamflow. I think you will say.
Oh no, we have a presentation in the second half.
Yeah, okay. So workflow management for hybrid cloud HPC infrastructures. So just to say, we are not only focusing on HPC, but the software might be useful even outside of that HPC community. There are some improvements to the common workflow language have been made. Those also went upstream. And there's a lot of work going on in integrating that and evaluating that with the applications, especially SpecFMD and the IO stack, that is CAP.io. We have components, further components from FORF, XMAP and TeraHeap, alleviating DRAM capacity limitations, so for managed and unmanaged languages. We have contributions from the University of Mainz regarding the PGAS programming models, so that we have not only MPI here, PGAS in the incarnation of GASP or GPI. And we have, of course, some low-level tools coming from INRIA, HWlog, that has also been adopted to the hardware peculiarities. All right. Third level of third task in that project, performance and energy efficiency tools. So we have a thing that has been renamed throughout the course of the project a little bit. It was known under Bull Energy Optimizer, is now Energy Optimizer in part of the larger Argos suite, let's say that. That is doing out-of-band hardware monitoring at 1 Hertz, is able to do power capping, works very transparently on Slurm level, so basically not much the application has to do there. We have E4 providing low-level components to access the prototype, board, hardware counters and sensors and things like that. So to be able to have a databases to build upon. And we have also ParaStation here acting as, again, an information hub via PMIX, collecting and forwarding sensor data. We have another component, part of Argos now, that's the dynamic power optimizer that happens on the node. It detects and classifies application phases and does some voltage and frequency scaling to improve efficiency of the application. And here, I think later on we have some results with the EC Trends and Dialog applications showing the effects of that. And what's important here already to see, we have tools with some overlap, but those the people providing those tools, they are working hard on integrating stuff. So there is integration going on between BTPO, DPO, Countdown and Merrick. What does Countdown do? It is a component that looks at MPI communication phases and tries to scale down voltage frequency in those cases where the application waits for some communication results. And we have Merrick that also dynamically tunes CPU and accelerator settings, but during computing phases. So those two complement each other very naturally. And so there is a lot of integration work going on. Merrick has been turned into a library, so can be used by other components and is used by Countdown, is used by DPO, is also used by LSU, for example. Yeah, so there is basically what I said, a lot of synergies, Merrick for hardware, Countdown for the interface with the application. So we do some real-time tracking of energy consumption using the hardware. That's basically for MPI, more or less, I would say. At least Countdown, Merrick is also does work for non-MPI applications. And the combination of those shows some very good synergies. that's to be shown later in the workshop. We have some more components from Jülich, Scorpi and Scalaska, also collecting application performance data, providing traces in Scorpi, and then in Scalaska doing analysis of those traces. And as I said, there is also an integration with Merrick going on that lab. Fourth part, for that very, very high level and quick walkthrough this work package is the I/O stack. So we have defined several tiers. So the high capacity tier, that is the integration with the hosting side. So some integration work going on there, accessing the high capacity tiers through Lustre gateways. We have the high performance tier, that means NVMEs. There some components, I will not go into details here, the key value store, also something by Forth, to be integrated with the IOC stack. IOC was one of the former projects where Eviden basically took the stack and ported it now to the hardware that we have here. We have the in-memory tier, things like CapIO here, and again, and Damaris. And here also some results will be presented, I think, with SpecFM 3D and StreamFlow together with CapIO. Last slide, I think. We have some application-specific interfaces. So ECMWF is in the project. They have their fields database, which you can see on GitHub, and that has been integrated with the key value store. And as I said, the IOC stack has been ported and integrated with the key value store, and we have some early prototype of a workflow analysis tool provided by University of Mainz. Well, yes, and that was the very, very quick walk through all these components that we have in the work package.
Very little software stack, Thomas. I mean, I think it's very easy to manage all this once there are just a few.
Yeah.